Good evening to all of you and welcome for this session on supply chain resilience. Wishing you all also a very happy and healthy 2021. I will also like to congratulate all the members of IPA and the pharma industry who have joined today, that we can be proud of the fact that despite very stringent lockdown and despite the pandemic conditions, the factories have been working and we have been ensuring that our products are available around the world. In fact, we were having some seminar with WHO and the US team of ARM, which partner with us. There is a great recognition of India that despite everything going on, we have been able to make our products around the world. And I would like to congratulate this team who have played a very important role, whether it is manufacturing, whether it is supply chain, distribution, that everyone who needs medicine gets medicine because medicines are fundamental for the health of the situation. Supply chain resilience is all about making sure that in a difficult environment, to make the product available. And that is what IPA has demonstrated. And we are the dependable supplier. Digitalization of supply chain is becoming very, very important. And that is helping us. Every company has taken digitalization, automation in this difficult situation. Every company has adopted the safety standards. Every company has ensured that the quality is maintained. And that has been always possible because of digitalization, because of automation, because of capability building. In fact, Shirish has been laying a lot of emphasis during all these programs where we have got best global experts for capability building. And we are trying to get the best global practices which can be adopted by Indian company. And thanks again to Accenture and Kinexis to come together and presenting their viewpoint on supply chain resilience. In fact, Rishabh talked to us around 2 to 3 months back, and Rishabh has worked very closely with IPA on the critical issues of ancillary industry because they were very important to maintain the continuity of the supplies. And there's an assignment which has been done on behalf of IPA. How do we partner with everyone to maintain supply chain efficiencies? Thanks, Rishabh, and the Kinexis team for doing this session. And without much ado, I will request now to Shirish to take over and introduce the speakers. Over to you, Shirish.
Good evening, everybody, and welcome to the program on supply chain resilience importance. This program is organized jointly by IPA along with the Accenture, and Accenture team is here. Let me introduce our speakers today. Rishabh Bindlish, who is the Managing Director, India Life Sciences Lead. He will be the coordinating the whole session. He is based out of Bombay, almost 20 plus years of experience and responsible for all lines of businesses for life sciences across the strategy and consulting digital and technological innovations. Another speaker is Mr. Akash Kedia. He's also Managing Director, Life Sciences and Supply Chain. He's based out of Bombay, 16 plus years of experience helping pharma clients for gaining profitability. Mr. Vismay Jani, he is a Senior Principal Supply Chain. He is based out of Bangalore and more than 15 years experience in large-scale transformation for the pharma clients. Other two people are from Kinexis, Mr. Christian Saab, who is Vice President Global Sales Kinexis. He's based out of Atlanta, US, and he has more than 25 plus years experience. Mr. Trent Bowman, who is a Director Business Consulting Kinexis, and he is based out of Maryland, US, and he has also more than 22 years of experience focused on establishment relationship with customer through sustained efforts. So I think now I request Rishabh to take over and move forward the program. Thank you.
Thank you, Mr. Belapure. Thank you, Mr. Jain. A big welcome to all the participants and wish everyone a very happy and safe new year. Like I was telling Mr. Jain a few minutes back, I see a lot of familiar names in the meeting and I look forward to an engaging discussion today. But before I start off, I wanted to take a minute to extend our gratitude to IPA for facilitating this session and providing us with the platform to engage with you all in this very pertinent topic. Thank you, Mr. Jain. Thank you, Mr. Belapure, for your constant guidance. And a specific shout out to Devang for helping us with all the logistic support. So thank you so much, Devang. So from an agenda standpoint, we have set aside 2 hours for today's session. And while Mr. Jain has provided some context on why this session is so important, at the start, I will take a few minutes to provide Accenture's perspective on the matter, especially having seen how the industry and supply chains have evolved in the last decade or so. I will then welcome Christian and the Canaxis team to give an overview of their firm and the product. And we will then dive into the actual demo of the product, right? And that is where we intend to spend a bulk of today's time for you all to experience what the product offers and how it can benefit. And having had a strategic and a long-term relationship with Canaxis, we will share some experience of our collaboration at a couple of life sciences clients and the outcomes we were able to deliver. While I would encourage you to keep posting questions in the chat window, we will hopefully have some time at the end of the session to take any feedback, questions, or queries. But just in case we are unable to, we can always connect offline for follow-on conversations. Next slide, please. I think if you look at the generics industry in itself, I think it's undergone a massive change through the last decade or so, but more important in the last 5 or 6 years. I think it's fraught with challenges. The first thing that we've seen is the heady years of 15%, 18% CAGR growths are a thing of the past. If I look at the last 4 years, I think the growth is muted globally and more so in the US. Not just that, we are seeing massive consolidation when it comes to our key customers in the US. And given that most of the generic companies have 60, 70% exposure to the US, the buying power of the customers is clearly shifting the scale. Not just that, we are also seeing with the FDA and the GDUFA timelines getting more and more aggressive. So they are approving more products, and that is also causing some glut in the market. So at one end, you have customers consolidation, right? And at the other end, you have more products getting approved. And the two is actually impacting the price erosion, which we've seen in the last 3 or 4 years to the extent of almost 9 to 11% every year. So the top line is under pressure, the profitability is under pressure. Then you have the entire FDA oversight. There is increased scrutiny from FDA on our manufacturing facilities. And in the last 3 or 4 years in the media, we've seen most of the companies come under the scanner of FDA. It not only creates a short-term and an immediate pressure with respect to product availability, but clearly from a long-term perspective also, there are significant challenges that the FDA scrutiny poses. And as the growth in US is slowing down, we are seeing companies actually de-risk their models and get more aggressive in emerging markets, LATAM, and rest of the world. But unlike US, which is a pretty homogeneous market with a limited product portfolio and a limited customer base, as you get into Europe and emerging markets, clearly the complexity of the markets and the complexity of the portfolio increases 15-fold or 20-fold, right? And India, we all know, it's a multi-echelon distribution network. And more recently, through the COVID times, we are seeing alternate channels of fulfillment like e-commerce, etc., also becoming more and more salient. And these will pose significant challenges going forward. Next slide, please. So the challenges that we've spoken from an industry standpoint will impact supply chain, are impacting supply chains, right? And one of the things we are seeing is that customers in the US, the 3 big ones, are expecting and more and more out of their suppliers. So the expectations of customer service levels are only increasing by the day. And about 7 years back, I remember when we did this program for one of our life sciences clients in India, the concept of failure to supplies was just not there. But in the last 6 years, these customers have gotten smart. They're possibly looking at this as an alternate revenue stream. So not only are they insisting on service levels to be met every week, every month, but they're also posing tough penalties just in case the suppliers are unable to supply to the customers over extended periods of time. And the failure to supply is a big offset on companies' profitability that one needs to watch out for. Clearly, as companies are seeing pressure on profitability from commercial and inline products, they have to get aggressive when it comes to new product launches. And from a supply chain standpoint, new product launches and getting the products launched on time without creating too much buffer in the system is another challenge that we see companies grapple with. While historically, about 8-9 years back, companies did not uh, give so much attention, focus on working capital, given the challenge that we spoke about on top line and bottom line. Increasingly, companies are also looking at their order to cash cycles. And the days where it was absolutely okay to keep 100-120 days of inventory is a thing of the past. So we need to maintain customer service levels at one point, but also balance it with the right working capital. And last but not least, I think what COVID has shown, and COVID can be seen more as an outlier, uh, we are also seeing certain spurts in demand, companies going out of stock because of FDA issues, etc. And there are opportunities that get presented to companies from time to time through NBO, through new business opportunities, etc. And in cases like those, the need for a rapid response and an agility in planning becomes extremely critical. And given that we are a generics company, how do we sweat out our assets? And how do we make sure that we are extracting most out of our manufacturing facilities is where scheduling comes into play. Again, historically, we have seen companies draw a line between planning and scheduling, but increasingly, we are seeing the remit of supply chain extend beyond planning onto the shop floor and onto scheduling. So the need for coordinated operations between quality, manufacturing, and supply chain is also becoming extremely critical. Next slide, please. And while we talk about the implications of these challenges on supply chain, we clearly see that there are some imperatives for the supply chain of the future. And to us, right, back with our own research, we believe that increasingly the supply chains of the future will need to enable end-to-end visibility, both upstream and downstream. We should be able to forecast and predict demand to the best of our abilities. Look, we will never get to a situation there will be 80% accurate on forecast accuracy in US or Europe. But the better we get at it, the better will the supply chain look like. We need to be able to enable or support businesses with a lot of scenario planning. If there are disruptions upstream or downstream, what are the potential options, pros and cons of looking at one option versus other? Today, we see that to be a huge challenge, and a lot of time gets wasted in coming out with recommendations. So the product or the tool should be able to give you this what if scenario capabilities. It needs to be very responsive and agile. And when I look at distribution more so in the India context, right, one needs to be also able to extend planning into fulfillment. And when all of these come together, that's what we call it as a customer-centric supply chain, which not only operates in silos, but is integrated across the entire value chain. Next slide, please. So as Accenture, we did a research with about 700 companies 2 years back, and we repeated that research last year. And what it clearly showed, what the research clearly showed, was there was masters who were very, very good at what they do, and they were the laggards, right? And clearly there were some traits that the masters had, and the common thread that binds the masters are these 5 elements. They configure their supply chain appropriately, which means the supply chain is not one size fits all, right? It is a segmented supply chain, hyper personalized, right? For a product customer combination. One needs to be able to do that, right? So that we treat different products differently, and the decisions and the actions that you take are all tailored towards a customer product combination. We should ensure that the supply chains are interconnected, which means that we cannot operate in silos. We need to be able to connect with our suppliers, our contract manufacturers, our third-party suppliers at one end. And we also need to have a very, very good understanding about who our customers are, who our customers are, right? And how do they sell? What are the patterns, so that we are able to use all of that data to plan better. We need to have the right operating model, the right structures, and the right capabilities within our organization. And the days of of a thought which says that I need to do all by myself is a thing of the past. in the new world, in a digital world, one needs to look at a hybrid workforce, which says that, look, there will be some things that will be done by humans, something that will be done by bots, something that clients will do, and something that can be done by external ecosystem players. So one needs to be able to look at those aspects when you operate the supply chain. And more importantly, as you invest in technology, data, analytics, one should be able to leverage all of that to optimize your day-to-day operation, and also look at new ways of innovation, right? I mean, one thought and one discussion that we're having with a client is to say that it is not just good enough to supply a pill to a customer. What if you were to work on a model where you're moving away from product to a services concept, right? So a part of it can still be based on what you're supplying, the quantity and the product, but a part of the compensation could be linked to your service levels. So moving away from product to a service mindset is something that a digital supply chain can drive and provide that perspective. So with that, I will, we can just move to the next slide. Right. Now, having set the context of what are the implications on supply chain and what the future of supply chain will look like, we believe digitalizing the supply chain is a absolute must, and it has gotten more. The need has been more felt now in a post-COVID world. While there were companies who have embarked on supply chain transformation programs over the last 8 or 10 years, I think investment in technology was still limited. But we are increasingly seeing a demand to say that, look, it is not good enough to just lay out processes. We should be able to automate it. And having worked with Kinaxis for the past several years, we believe this is one of the better products tailored for life sciences. And what we want to do now is spend the bulk of our time going through the demo. But before we do that, I would request Christian Saab to come up and give a brief overview about the company and the product. So Christian, over to you.
Thank you, Rishabh. First, I want to thank Accenture and IPA for bringing this group together, and for the folks joining remotely in India. Appreciate everyone taking time out of your evening. So if we can go to the next slide. I think supply chain has never been as important as it has today with the current pandemic of COVID. And I think what it's taught a lot of companies is adding more people in Excel spreadsheets isn't solving the problem. So today we want to share a bit about who Kinaxis is and the uniqueness of our platform and what makes us different. 2021 is a unique period for Kinaxis as we have a tremendous amount of new capabilities rolling out with new user interface. We've opened up our platform to our partners who are ultimately the domain experts, and they're able to bring their unique knowledge and build out pluggable analytics and applications into the platform. So that's new for the company. We have things like truckload building and really point solutions adding to the platform, which will certainly add on to our 600 people in R&D who ultimately have a 6-quarter roadmap. If you look at our R&D expenses, for a mature product, we still continue to invest heavily. Global expansion. We're actually at 1,000 employees right now in 25 countries, and 75% of our hires in 2020 were outside of North America. I think as a pharmaceutical company, security is important when you look at any technology. Going back 10 years ago, Bristol Myers Squibb encouraged us to achieve SOC 1 and SOC 2. And it was a requirement out of the office of the CFO because they were looking to put in consolidated costs and financial data in their formularies, the most sensitive data. So when you look at Kinaxis, every deployment, each customer has their own production test and dev, and all of those are protected with SOC 1 and SOC 2. I think financials are important when you're evaluating technology. We're ultimately looking for long-term partnerships, as are you. We have a very frugal CFO, so we're proud to share that. We have 11 years of profitability in a strong cash position. We're actually the top 30 stocks traded on the Toronto Stock Exchange today. The Gartner Magic Quadrant, we've placed the last 8 years in a row. In the last 3 scorings, Kinaxis has been #1 in terms of the ability to execute, and also completeness of vision. And that means, do we continue to innovate and grow and expand the product? If we can go to the next, please. Life Sciences business unit is incredibly important to Kinaxis, and so important it's now our #1 and largest industry sector. I've been at Kinaxis for 10.5 years. When I first came here, we had 2 customers, and today we have close to 50. And this is just a small sample of some of our customers today. 6 of the top 10 global pharmas deploy Kinaxis. Very proud to say Dr. Reddy's is our first India-based pharma. So we look to have them as our absolute showcase, and that's a joint effort between Kinaxis and Accenture. When you look at these companies, it's important to understand that Kinaxis is not a point solution. These organizations truly brought us in to be their end-to-end supply chain planning platform. All of these companies are going through supply chain transformations. And when you look at where our deployment sits, we sit everywhere from raw materials, API, formulation, granulation, packaging, connecting to CMOs and CDMOs. Ultimately, it's a crawl, walk, run approach. We have tremendous experience in this industry. We do tremendous amount of co-development with these companies. Companies like Sanofi, we've been working on production planning, campaign planning, rhythm wheel, and there's a 5-quarter roadmap of enhancements. When we look at the complexity of integrating, multiple ERP systems, Novartis had 21 instances of SAP, which we had to integrate in the first phase. So Kinaxis is able to sit on top of all of those source systems and pull that data in. And the first time, all these planners are seeing all their data in one central repository. The power of what-if analysis and simulation. Companies like Amgen, they can receive a tender in 24 hours. They can determine not can we bid it, should we bid it? Because they've looked at every permutation. Do we have API? Should we add overtime? Should we pre-build? So ultimately, their planners are eliminating the excuse, I didn't know. If we go to the next slide. Being dominant in an industry doesn't come easy, and there's a cost and there's a timeline to that. And when we first decided to focus on this industry, we went and reached out to, at the time, Amgen and Genzyme, and we asked, what would it take for Kinaxis to be a dominant player in life sciences? And what they shared is their legacy solutions were missing critical analytics for the planners. Analytics and algorithms like jurisdictional control, attribute-based planning, tender management, lot for lot. We have dozens of these type of analytics today that are pre-built. They're native to the platform. What this represents is faster time to deploy, lower cost to deploy. Without those analytics, all of those are being built as a one-off or a custom build. And then there's doubt, do the analytics work with one another? Can they scale to large volume of SKUs, especially within the generic space? Can they scale to large volume of users? Today, our life science customers, some of them have as many as 1,800 users on 5 continents, running thousands of simulations per month. So over the years, we perfected the ability for speed and scale and making sure these analytics are giving the results the planners are looking for and accurate results. If you go to the next. So we're going to get into the demo here in 2 minutes. Let me socialize everyone what the Kinaxis platform is. And notice I'm saying a platform because we're not built around modules. So if we go back to when Kinaxis first started out, their entire vision was, how to make an MRP run go faster. So think about 30 years ago, an MRP run would take 4 or 5 weeks. So the whole premise was Kinaxis created an in-memory database and in-memory engine. They were really years ahead of their time. Now in-memory is popular. Companies are trying to, master this type of technology. But we have 30 years in terms of perfecting it. And the entire premise was built around solving the math and the analytics of supply chain. So first of all, it was purpose-built for supply chain. It wasn't a catch-all to do human capital management or CRM. At the heart of it, that in-memory database is a 24/7 demand supply balancing engine. And that engine's always on, so nothing ever has to be run in batch. What feeds that, think about that as a human brain. What feeds that brain are all of your source systems. So we pay the ERP vendors like SAP to certify our adapters to things like ECC and S/4HANA. So we connect to all your source systems. We cleanse, match, merge, harmonize. Within the first few weeks, your planners will see all of their data in one central repository. And we're looking to, harmonize that data. We're looking for inconsistencies on units of measure and dosage and foreign currency. The next layer is our machine learning. We call this self-healing supply chain. And we're very deliberate on the use cases that we've set out to build. The 3 use cases that we're addressing are lead time, yield, and demand sensing, demand forecasting. This area in the gray is incredibly important. If you're a planner, this is where your planners and those teams will live. Any planner can simulate anything at any time, and they can do it in seconds. And what makes our simulation capability is different from the rest is our ability to have multiple planners in a sandbox environment simulating while other planners are executing to plan, and we're tracking both of those. We have alerting capabilities. If there's a disruption or we get inbound demand that outstrips inventory, who needs to take action? What if we have a tsunami or a fire in one of our DCs or manufacturing sites? Well, typically when there's a disruption, it takes a day to figure it out. Then it takes another day of email exchange, and then now planners start passing Excel spreadsheets. This process is now all automated within rapid response, that alerting capability. Planners can ask other planners to collaborate in sandbox environments. They can run simulations and what if analysis. As executives, you can set the benchmark and the scoring so planners know what their targets are. Maybe this quarter is more important for profitability or service levels or margin. So all this can be presented in a scorecard, which you'll see today. All these analytics can be pushed out to the tablet and the handheld, so executives can look holistically at their supply chain nodes and understand the health and the status. The final layer of the platform is the application layer. Ultimately, this is how we monetize. So every company starts their transformation journey differently, but ultimately the platform is all interconnected. There's a notion called concurrent planning. Think about holding a rope. If I'm holding one end and you're holding the other and I pull it, you'll feel the tug. Concurrent planning is capable because we are a platform. Everything is inextricably connected. If you make a change in demand, it will ripple effect on supply, inventory, and capacity. It is impossible to make a change in one area and not see the ripple effect in the others. And this provides the end-to-end visibility. Because of this concurrent planning, I'll take a quote from the Chief Supply Chain Officer of Mylan. He said, because of rapid response, in 3 years, we won't have demand and supply planners, we'll have network planners. And the reason he said that is now planners have visibility through all the geographies. If a planner in Asia Pacific, the old way, solves a problem, they go home for the day, Europe comes online, but now they realize that they just had their API taken away. This is avoided within Kinaxis because of that end-to-end visibility. So the platform is incredibly powerful, is very functionally rich. Through recent partnerships, we are now able to go down to detailed scheduling to the hourly and sub-hourly. And then, as I said, with co-development effort with companies like Sanofi and Merck, we're getting better at the campaign planning and rhythm wheel. So a lot of the co-development directly benefits, the other customer base. So we're very excited for that. And if we build out the next piece here, one of the important pieces of the platform is every deployment is configuration based. And this allows speed to deploy. Point and click, drag and drop. A lot of the IP went into getting away from coding in a deployment. The worst thing you could have in a cloud environment is coding. I'll give you an example. Merck, which is our largest pharma deployment today, their upgrade process took less than 2 weeks. 95% of our customers are all on the same version. And this is possible because every deployment is a standard deployment. What brings the uniqueness to each deployment is the configuration of that deployment. So the workbooks and reports, your dashboards, your task flows, your scorecards that are unique to each planner are all configuration and not coding. This means your organization are able to make these changes and are not dependent on Kinaxis doing that. And when they make those changes, it's all standard. So with that, I'm going to pass over to Trent. We're going to get into the product demonstration.
Okay, excellent. Can everybody hear me? Or can someone even verify that you can hear me?
We can hear Trent.
Okay, excellent. If you could just go to the next slide, please, and just go ahead and build it out. So I have 3 slides just before we get into the solution itself, just to kind of do a little bit of additional setup on the capabilities of the rapid response solution. So first of all, when we think about supply chain systems of the old traditional approach, if you will, typically this type of supply chain approach would be very cascaded and sequential. And what I mean by that is you would have demand planners doing their work, and when they're done with their work, they publish the demand plan. Typically, you would also have situations where demand, supply, inventory, and capacity would be doing their work, and when they complete that work, they have to publish it to get an S&OP view or a financial view of the work that they have done. Well, in that traditional approach, it's very static and siloed, and typically it's batch job driven. And also, one of the things we've seen historically is that scenarios are segmented very often by function. And so when you think about scenarios by function, if I'm doing scenarios on my demand plan, I'm not seeing the impact of those different scenarios on whether or not I can even meet that demand from a supply, inventory, and capacity perspective. So Kinaxis' approach, which is represented on the right, is a little bit different. And Christian already alluded to this to some extent, but we really have a philosophy of concurrent planning. And we'll see this in the demonstration today. But really what concurrent planning is, if I move the cogwheel representing demand in red, the supply, the inventory, the capacity, and the S&OP cogwheels all move in coordination with the movements that I'm making with the red cogwheel. This is a real-time and integrated platform. There's no concept of batch jobs whatsoever. And then most importantly is that your scenarios that you run are cross-functional. So we have the ability to do a digital twin snapshot of the entire supply chain. And that entire supply chain snapshot is our what if scenario. And that what if scenario can be done across all the functional silos, and you have visibility into all the components based upon any snapshot or scenario that you create. And so it's that powerful capability that, and again, you can have as many scenarios as you want, that gives you the ability to make business decisions and try them out before you actually execute them or turn them into your live supply chain scenario. Next slide, please. Go ahead and build this out. So if we think about this concept of concurrency, scenarios, collaboration, how does that impact your business? So first and foremost is we have a digital data platform. Rapid Response, as we mentioned, is the name of our platform, the database, and also the solution you're going to see today. But that platform gives you the ability to essentially model all elements of your supply chain. And the idea is it's built, purpose-built to model supply chains. And so all the elements of things like lead times, bills of materials, production rates, production yields, so on and so forth, are all inherent to that digital data platform that we provide. And then built on that platform is the concept of the concurrency and speed. From a business perspective, why that's important is this means that the system doesn't require batch jobs, it eliminates information latency, and it removes modular thinking. So people are thinking about, and practitioners and users in your systems are thinking about the supply chain holistically, as opposed to their own functional slice. And then versioning in scenarios. It's very key to be able to understand that if I have a demand increase or I have a disruption, start to analyze and understand the impact of that disruption before it's fully implemented or before you're fully executing against that. So what are all the different alternatives that I could do to solve that disruption? I can test all of those out using a digital twin snapshot. Those digital twin snapshots are forward-looking, and they're also historical. So I could take a snapshot last week, last month, last quarter. So when I have that disruption that occurs, I'm going to be able to compare, well, what's different about that disruption from the last time we saw a disruption, or what's different from that disruption from last week? So all of the changes between one scenario to the next are always tracked. And this is the power of, the purpose-built supply chain database, and the fact that it's built to understand that versioning concept as well as the supply chain concept. And then last but not least, a lot of times with control tower solutions or supply chain solutions, you hear about end-to-end visibility. Well, we're really focused on end-to-end transparency. And the difference is transparency is about not just visibility, but visibility and accountability. And when you think about accountability, it's each of the stakeholders in your supply chain has visibility to the issues that they're encountered with, but they also understand what they need to do to potentially resolve them. And that is facilitated through the concept of every element, whether it be a production asset or a material, whatever the case might be, has specific users assigned to responsibility for that particular supply chain entity, if you will. And then there's collaboration that's wrapped around that. And the collaboration enables the key stakeholders to collaborate almost in like a Facebook-like or LinkedIn-like collaboration engine to resolve those particular issues. And it's the reports, the dashboards, and that workflow that enables them to complete that resolution, if you will, of any type of a supply chain issue. And all of that is also fully mobile enabled, and it's also tied to a financial model. So when you think about tied to a financial model, you'll be able to see the financial impacts of every decision you make within Rapid Response, because we are tightly knit and tightly tied to that financial model. Next slide, please. And so this is my last slide before we get into the solution. What I want to just point out is that we believe everything we just discussed, the digital data platform, concurrency and speed, supply chain versioning scenarios, and transportation and collaboration really give you a foundation for supply chain resiliency. And if we just simply looked up the dictionary definition of supply chain, of resiliency, and apply that to supply chain, it's really the ability of your supply chain to respond and recover, in this case using Kinaxis in real time, from unexpected events and move to a state of increased customer service, market share, or financial performance. So I think this really encapsulates in one sentence or one definition the objective of all the things that we're talking about. Digital data platform, concurrency and speed, scenarios, and transparency give you the capability to have a resilient supply chain. So with that, any questions before I jump into the demonstration? All right, I'm going to share my screen. Okay, you guys see my screen? Can I get a confirmation from somebody that my screen is displaying?
Yes, it is visible. Right.
Okay, and you see a dashboard
Yes.
in the screen?
Right.
Okay, excellent. All right, so first and foremost, welcome to Rapid Response. I want to introduce you to one of the dashboards you could be using within the solution. So first and foremost, these dashboards, you're going to see a couple of them today during the demonstration. First of all, I'll mention that I have the demo broken into 3 different pieces, and I wanted to give you guys a kind of a comprehensive viewpoint of the different capabilities within Kinaxis. First, we will look at an S&OP type of process. So how can I use the rapid response solution to understand disconnects between my annual plan and what I'm trying to accomplish, and how can I do things within the solution to close that gap. Second, we'll look at using rapid response because it's always on, and because I'm able to understand disruptions that are occurring in the supply chain at any point in time. We want to use it to as a control tower type of solution to see the impact of events that are occurring. And then last but not least, I want to show a little bit of our detailed scheduling solution. So I'm going to spend maybe 15 minutes in each of those, or whatever time we have based upon, I think we actually have a little bit more time than that, but that's okay. So with this dashboard you see here, this is purpose-built to facilitate my S&OP process. First and foremost, I've mentioned this concept of collaboration. So in this example here, we have been mentioned in a collaboration. I'm going to drill into that. And what we're going to see is that I have been asked by our executive within my organization to help close the gap to the budget that we have for Q4. So if I view this collaboration that has been created by our executive, what he or she has identified is that we have a budget gap that they have highlighted very clearly within their version of the solution of, hey, we have a gap in October, November, and December of this year, and we want to be able to close this particular budget gap. So what I'm really just illustrating here is, again, the idea that you get out of email, you get out of Excel, you're making decisions and collaborating with individuals and key stakeholders within the organization using our inbuilt collaboration functionality. So in this case, the executive has asked me to take a look at this and to help close that gap for Q4. Now, what that does is that takes me as a user to my dashboard. And so I log in as that individual who is in this case potentially an S&OP coordinator to try to resolve the problem that the executive has asked me to resolve. In this particular dashboard, I have multiple widgets. Each of these widgets can represent different pieces of information. And again, this can be purpose-built based upon what I'm trying to accomplish, in this case, an S&OP task. In this case, I'll drill into the specific alert or area that the executive has asked me to focus, which is into the consensus demand plan. And so looking at the consensus demand plan, first and foremost, I have off to my left my product hierarchy. This is giving me the ability to look and slice and dice on any level of my network that I need to look at. If you recall, we had an alert saying I have a gap in the financials for Q4. And today's date in the system that I'm using for the demonstration is June 1st. So this is in Q4 of 2020. And you can see very clearly on the graph that I have a gap being identified by the system, represented by the red bars, of the amount of the plan that I'd like to achieve from an annual plan perspective, represented by the black line. The current plan in the system, represented by the light blue, as to where we're at right now, tracking towards that annual plan. And last but not least, the current gap that exists between what I'd like to accomplish in Q4 and what the current plan based upon demand and supply is suggesting. You'll notice, and I mentioned this up front, that one of the key things that we're tying to throughout this entire process is we're also tying to financial information. So we have within the rapid response model the ability to represent the cost of manufacturing all the items, whether it be material cost, manufacturing cost, fixed costs, et cetera. We also have the ability to represent the revenue that's going to be achieved from selling that product. And so what ultimately that gives us is a complete financial picture all the way down to like a cost of goods sold and a profit and loss picture of anything that you're doing within the supply chain. So in this case, I'm looking at information by revenue. If I wanted to slice and dice this hierarchy in any way, I can do that as well. So if I simply come up and pull up and say I want to look at customers as well, I can look at customers by group. If I want to pull up my hierarchy and look at locations, I could also pull up sites, and I could look at whether or not I'm at one of my facilities in Hyderabad, Bangalore, or Calcutta. And you can basically slice and dice this information in any way that you want. So these hierarchies are completely user definable. And also I can combine them to create different intersections of the business based upon what it is that I need to review. So with that, let's dive into this issue that I have. We notice in this case that it's in my oncology business. So I want to be able to solve this problem and close this gap. Notice that I can look at this in units as well. So everything from a supply chain perspective can be obviously looked at financially, but also typically most supply chain practitioners want to understand the unit impact of the plan that they have within the system. So based upon that unit impact, I can see that I have a demand deficit of 50,000 units, 55,000 units, and 86,000 units respectively in that Q4 time period. So what I might want to do as an S&OP coordinator or working together with marketing or sales is try to figure out ways to close that potential gap. So first thing I might want to do is I might want to evaluate ways that I could close it in this scenario. So for example, in this case, I'm going to go ahead and create a scenario. And we talked about the concept of what ifs. So let's just call this scenario. Maybe one way is I can work with sales and I can activate some tenders. And those tenders could potentially have additional sales opportunities that I could leverage to help close that gap. So what I've just done there, and it seems rather trivial, but I just want to point this out, is I've created a complete snapshot of my supply chain with that simple click that I just did. And I don't know if anybody had a stopwatch out, but that took maybe 2 seconds once I clicked OK to create that digital twin snapshot. And so this is what we're talking about when we talk about the concept of what if scenarios, the concept of speed in the sense that I can create a what if scenario at any point that I want. It's a complete snapshot of everything that's happening within the supply chain. And it takes literally a second or two to do so. And so now with that information, I can drill into, in this case, my tenders. And I can look at, in this scenario, opportunities that I might have to take on additional business. And notice these additional businesses, there's certain opportunities out here for additional product that I could sell, but they have probabilities associated with them as to whether or not I could truly secure that. So a great way to evaluate something like that is to do so in a scenario so that I'm able to understand, if I were to get the probabilities, the high probability business, the 90%, the 95%, do I have the capacity, do I have the supply to be able to address and meet the demands associated with those particular tenders? So let's find out. I click those 2 tenders, I click save. And now, again, not to trivialize this, but clicking the save, I've just invoked the concept of concurrency. So it may not seem like I've done much, but I click save, the system has done a DRP, an MPS, a capacity plan, an MRP. It has done, and I'll throw out more Apex terms, it has done the entire supply chain plan literally as fast as I clicked that save button. So again, you could have pulled out your stopwatches, it would have been a few seconds for it to have evaluated all the impacts up and down the supply chain to figure out, can I meet that additional demand associated with those 2 tenders that I decided I wanted to look at? And what you'll notice immediately is that it has now evaluated some demand plan that is at risk. And so what we mean by demand plan at risk is it's gone up and down the supply chain. It's figured out, do I have enough capacity? Do I have enough supply and so forth to meet that demand? And it's evaluated that I have some supply chain constraints that are going to keep me from meeting that full demand profile. So in this particular case, I can continue to drill into that and see more detail. So as I click on that demand plan at risk, it's going to bring up for me a visualization that shows me, what is at risk. So this is the concept of a tree map. And in this tree map, what you're going to be able to see is I can see information by site. I can see information by product group. I can see information by a combination of the two. So basically I'm slicing and dicing, and these group bys can be set to anything that you want. But basically in this heat map, tree map type of view, the bigger the box, the bigger my product quantity or volume is that I'm selling for that particular product group. The color of the box is shown by a combination of either the total number of planned units, which is I can set to the size, or the units at risk. Here I'm looking at the total number of units, and the units at risk is being represented by the color and the gradation of that color on that particular block. So for example, the closer I get to red, the more units and demand that I have at risk based upon the current supply chain constraints. The closer that I am to green, the better that I am in that particular area. And again, I can slice and dice this any way I want. So as I look up and down the supply chain, you'll notice how dynamic it is. And I'm able to see all the different, as I drill in, I can drill into the, the hierarchy. This hierarchy is completely user definable. So you can see here, there's a lot of flexibility to see the information that I want. If I put my mouse on top of any of these, excuse me, I can see the total number of planned units for this particular product in the oncology group, the total number of units that are at risk, the percentage at risk, and most importantly, how much revenue do I have that's being potentially impacted by the shortage. So this is, 16 million in revenue. That's something that I want to be able to address. So I simply double click on this, and I can now drive into some of the root causes of why this is happening. So in particular, we have those 4 products. So I drilled into oncology. We have those 4 products that we mentioned that are causing me an issue. I can see the quantity across each of those that are short. I can see the time period of when they're going to be short. So that's going to be in November. So I probably had enough production capacity to meet the demand as I got into October. But because of that increase in taking on those tenders, I eventually end up with a backlog. And that backlog causes me to have an issue in the month of November. So again, just continuing the idea of drilling down a little bit further, I can start to see specifically what that inventory profile looks like for all of my oncology products. So as I get in that plan, I can see, specifically the constraints, the overload constraints and the shortage that's occurring out here in November. And I can see the constraint that's associated with that particular shortage during that time period. And so last but not least, let me drill into and find out specifically what's going on with that particular production asset. Let's just toggle over to our scenario. So what you're essentially seeing is, and again, I'm looking specifically at one resource in this case, just to give you an example, but I would be able to look at all of the manufacturing constraints that are causing me issues with not meeting this demand. I would be able to look at all the material constraints that are causing me issues to not be able to meet this demand. I would be able to simultaneously consider the production, labor, and material constraints and understanding the availability of my supply. So in this case, I'm looking at, I'll reference you to the top here for 1 second. This is my overall capacity in weekly periods to produce on this particular production asset. Here is my current manufacturing load. Any place where I have an over or under load and scheduled usage is going to show me the comparison of those two. So, and if I were to drill into any of these, I could see specifically which products I'm producing. So it goes down to the level of detail of understanding, exactly what work orders would I be producing on that particular line. Are they tied? And this is one of the great things about the solution as well. It does full pegging upstream and downstream. So when you think about things, and Christian mentioned this around some of the life science capabilities that we offer. If you think about things like jurisdictional control, where I'm producing a product in a certain country and it has certain markets which is either excluded from or included to be able to service. So I have the ability through the attributes of where the demand comes from and where the supply or the product is being produced to link demands that are eligible to be replenished from that location versus demands that are not, through this concept of jurisdictional and attribute-based planning. Likewise, I have the ability to handle things like expiry. So if I know how long I have to either consume or use a work in process ingredient, either an API or some other semi-finished product, I can represent that. If I have a shelf life on the finished product, I can also represent that. And it's using this information that it's going to generate detailed level production work orders or consume supplies that are already existing in order to create that production plan. In this case, you can see I'm overloaded. If you look down here at the graph, the black line is a representation of my overall capacity, which is again shown at the top in the grid as well. The load is how much am I using of that capacity for each of those time periods, and the scheduled usage is what am I actually producing during that period. So what I want to be able to do in this case is understand, why do I have these overloads and what can I do to potentially resolve them? Well, in this case, you'll notice there's lots of gaps prior to this plan. And this is done just very purposely, just as a simple example. So here I'm using all of my production assets, but I have lots of capacity available in the months leading up to that Q4 time period. So what I could do is I could actually control the constraints of that line. So right now, again, I'm looking at this one manufacturing line, and I have 12 products being produced on it. I could actually let the system, again, completely in scenario, produce this product earlier. So putting in the concept of a -1 here, I could say go forward 90 days, pre-build 120 days. -1 simply means to us that it can pre-build as far as it wants. Now, I mentioned the concept of shelf life. So if you do have a shelf life defined in this item, that would be another constraint that I would respect that I could use in the system. I click save. Again, this illustrates the concept of concurrency. Immediately upon the clicking that save, it is now rerun the entire plan from soup to nuts to say, boom, here is now the load level plan based upon the adjustment that you just made across the entire planning horizon. So again, the idea of concurrency is being illustrated here in the sense that I have made an adjustment. I've done that adjustment in scenario, and now I want to see the impact of everything on my supply chain based upon that single adjustment. Now, and last but not least, let me talk about the concept of what we call playbooks. So what you've seen here is one example. I have created a scenario, again, very quickly. I have made a change, in this case, a single change to say, allow production on the constraining resource, in this case, to be pre-built. And by the way, before I go any further, let me just drop back for 1 second in this scenario. And you notice, again, the idea of concurrency. I'm in the scenario. Remember where we started. We started here. Whoops, started here, where I had the issue. And now I'm in a situation where I've removed that issue. And when I remove that issue, everything is now turned to green. And so again, the point here is that we had an issue, we resolved it. I've now see that that demand is 100% met on time. But when I think about the different things that I could do within the system is I could have done this interactively, but I also want to be able to do things automatically. So what we mean by automatically is we have the ability when an event or a situation occurs is to automate a lot of the stuff that you just saw. So I could automate a pre-build, I can automate using alternate sources, I could automate an activation of a third shift. And so the idea here is that you are letting the system do what I just demonstrated automatically. And then it presents to you multiple different scenarios to say, what's the impact financially of activating an alternate source? What's the impact financially of activating that third shift? And so the idea then is I can compare each of those different scenarios side by side. So in this case, I wouldn't have had to necessarily do anything. If I have that gap in the Q4, I could have invoked, well, let's activate some tenders. Let's then look at alternate sources. And the PB here means the playbook, basically. And this is all being automated through the system. Let's automate the pre-build. Let's automate the overtime. And so what the system could have done when I tried to close that Q4 gap by activating the tenders, this would have been a user-driven action, and the rest of these would have been automated action. I could have then evaluated how does that impact my supply chain across each of the key metrics. How does that, and these metrics are completely user definable, plus we have about 100 some out of the box. So revenue, margin, revenue that's at risk, which means, potentially constrained supply in the supply chain, the on-time nature of my supply chain, my constraint utilization, and also average inventory. So if I look at the starting point, this is where we started. I now had that increased demand in order to close the gap. So you could see very clearly that the revenue would go up. Then I moved to, okay, what happens when I try to service that demand through an alternate source? What happens when I try to pre-build? And what happens when I try to run overtime? And again, the key here is that these scores are being calculated based upon the combination of the weights that you want to assign to each of those metrics. And I can evaluate those based upon that subjective score based upon my user-defined weighting to figure out which one of these potential scenarios makes the most sense. And then last but not least, to tie off the scenario, is I might want to share that. So if I create the collaboration that the executive had asked me to do, and I say, okay, Mr. or Miss Executive, I've evaluated overtime, pre-build, alternate sources, attached is the result of that analysis. Please let us know which one of these scenarios you'd like us to commit. And so this is an output of the scorecard that you just saw, and I would be able to share that with all the other key stakeholders in the organization, and then we can make a decision as to which scenario we would commit. Okay. Any questions? That is essentially the first demo vignette of an end-to-end example. Let me just recap what we did. We had a gap in the Q4 plan that was identified by somebody in the organization, in this case, an executive. That executive kicked off a collaboration. The collaboration drove somebody else within the organization, in this case, myself, as the S&OP coordinator, to look at potential ways to resolve that. And of course, in a typical production situation, I could have pulled in a plant production planner, I could have pulled in a material planner, and so on and so forth. There could have been a lot of folks and stakeholders involved in that evaluation. Ultimately, we ran multiple different scenarios. We showed interactively how to do one, which was a pre-build, but the system could have also automated a lot of those steps for us and then present back each of the different alternatives and the financial impacts of those and the side-by-side comparisons so that we make a decision as to how we should move forward. Okay. I'll pause.
Then this is fine. Let's keep moving.
Okay.
And there's just a question on the chat room.
Yeah, okay. Is there a question? Can you read it
to me? Or? There's just one question that you might want to answer. It says whether Kinaxis also gives optimum solution while running simulation instead of giving scenario.
Great question. So yeah, absolutely. When we think about this concept of alternate sources or pre-build or overtime, what you're able to do, and I kind of term this as a rules-based optimization is the best way to define it, is we will look at, we know what the primary source is based upon the least cost place to produce. We'll then look at the alternate, which is the next least cost, but we'll only use that when we run out of capacity at the primary, and so on and so forth. So basically it's doing a full demand supply matching based upon the rules you've set up. And the beautiful thing about that is you're getting an answer very, very quickly. And it's very near optimal based upon the concept of, I know where my least cost, next least cost, and so forth is. And I basically set that up as a rule within the system. So I hope that answers the question. I'm happy to dive into that in more detail if I need to.
I think it's fine, and Trent, we can move on.
All right, excellent. Let's move into our second example. So our second example is a little bit of a different perspective. So the first example, we were focused on a perspective of what does the supply chain look like? What am I doing for S&OP kind of further out in the planning horizon? So if you remember, our starting date was June 1st, and we were looking at the plan out in October. In this situation, we're looking at more of a control tower example. How do I handle last minute disruptions or things that occur within the supply chain and be able to respond to events? And so again, because Kinaxis is always on, because there's no concept of batch jobs, as soon as we get a new piece of information, we're leveraging that new piece of information to evaluate, respond, and confirm in the supply chain. So the idea here is that the system is always on. So one of the things I could look at is I could look at my supply chain, in this case, in terms of a graphical perspective. You can see here, I've got different manufacturing facilities. I've got different endpoints where I'm meeting demand. So I can see as I click on any location, if I click on Bangalore, I can see the different locations that are being serviced by Bangalore. If I click on Hyderabad, I can also see which locations are servicing it as well. One of my manufacturing facilities, where that flow is. And so all the information within the supply chain, I can see kind of on a graphical perspective. And again, this is just another purpose-built dashboard, a view of information within the system to help me understand what might be happening, in terms of where do I have supplier constraints, where do I have manufacturing constraints, what's my current, demand performance and sales order performance, et cetera. But what you'll notice here is I've actually received a change in my supply chain. And literally this just occurred just now. So the supplier has notified me that there's going to be a shipment delay. So if I wanted to drill into this message, I could actually look at what's happening, click here for details. So right now I've received a note from a customer, or from, a supplier, that there's a plant shutdown and the deliveries are going to be delayed. The original delivery date of these deliveries was June 20th. Remember, in my system, the planning date is June 1st. So they were probably going to ship them right away. around June 1st, and now I'm currently receiving these products on these shipments on July 27th. So you can see that this has caused, I don't know if anybody noticed this, but this has caused some of my widgets, we call them, which is used, or the little tiles here within the dashboard, to have an impact. So it's caused a constraint issue. It's caused a supply or material issue. It's also caused me to have some late demands, all simultaneously based upon this delayed shipment. And likewise, down here below in my geo map, I'm seeing the impact of the locations that are affected by this particular supplier shortage. So in particular, Hyderabad and Bangalore both have an impact of shortages based upon that particular shipment being delayed. So if I wanted to see the impact, in this case, I'll drill into Hyderabad. I could see, if I double click, I could see specifically what's happening at this location based upon that late shipment. So as an example, this is all of the orders and forecasts that are being serviced out of that particular location. So you can see here that I can not only see the aggregate level information that we saw on the previous screen, but I can also see the detailed level information. Now, I might want to focus to say, like, okay, I don't care about necessarily everything, but maybe I do care about things that are greater than 14 days late. And what I'll be able to see is, let's start there and kind of see what's happening within the supply chain. So first and foremost, if I select that item there that's 14 days late, what I'll be able to do is to see all the details related to that particular demand element. So first of all, it's a very big order, $7 million potentially. And right now what's late is a pretty good chunk of that. And this is the revenue that's being impacted that I need to potentially resolve. So I can also see in the supply chain where the issue is. So by clicking on this link that I just clicked on a moment ago, I'm seeing a complete picture of the full supply chain for that item. So I mentioned before that we have the ability within rapid response, all within memory, to manage, the full depth of your supply chain. What APIs do I need to service the overall, manufacturing process? What's the, granulation, encapsulating, coating, whatever is taking place in the manufacturing operation to produce a finished product, and then ultimately packaging this necessary, and then ultimately the end customer demand. So I can see here, in this case, the full flow of this product throughout the supply chain. The areas that are highlighted in green are the nodes of my supply chain that are in good condition right now. Demand and supply are balanced. And the areas that I see are in yellow, and again, the closer they get to red, the worse they are, is where I have issues. And right now, my gating supply is represented by this one part or product at this node of the supply chain for this to service this particular order. So it gives me a sense of, what is the customer impact of that particular material shortage in this case within the supply chain. And I'm just going to close a few of these to give us a little bit more room here. So what I might also want to understand is, what are the materials that are affected? So there's a supplier shortage. I looked at the demand picture. Now with that supplier shortage, I want to look at the supply picture. So what are the gating materials that are driving this particular issue? And I drilled into my gating materials, and I can see them, multiple different ways. So I might want to see, for example, what's my revenue risk by region based upon the material shortage? What's my revenue risk by the detail? So if I wanted to see specifically, each of these components, what's it causing me to have in terms of late demands? And I could basically look here again, anything greater than 0, it's showing me the impacts adding up to that 100 million, if you will, of the total impacts of demands that I have. So in essence, the one here that's causing me the most grief is this raw material or component part D2512. So if I think about how to potentially resolve this issue, what I want to do is I want to figure out ways to take on the most important, the most gating requirement, which is this guy right here, and try to see how I could resolve that. So if I go take a look at a planning profile for the D2512, I will be able to see a complete picture of the supply and demand. So remember, this is a component that's needed through a bill of material relationship. So here's the demand picture. Here's the supply of what I'm going to be able to meet. And then most importantly, here's the balance. And you'll notice anytime that balance is starting to drop below my safety stock target, represented by the black line here, or the value you see in this line here, that it's going to start to highlight that. Anytime I start dropping below, and I'll just blow this up a little bit, anytime I start dropping below 0, which is basically representing the fact that I'm now going to stock out of that material, and I'm now going to have an impact on customer orders, forecasts, et cetera, based upon the fact that I'm stocking out, it's going to represent that in a negative value. Now, when I look at ways that I could potentially resolve that, I could look at alternate supply sources. And now I have a couple different things I could do here. So again, number one is I could run this in a scenario. So if I wanted to evaluate what the alternate supply sources looks like before I actually commit to it, I could do that. Or if I wanted to do it in live, I could simply change it in live as well. But what you'll notice is I've got two different supply sources. The first supply source is a 20-day lead time at a reasonable material cost. The second, and by the way, notice this is a very minor ingredient, right? But it's still causing me, maybe this is, I'm dyeing my pharmaceutical product blue, and ultimately it's got to be that color to meet the government regulated recommendations or specifications for that product. So I've got to have that. It's not going to be something I can sell without it, but it's a very minor commodity-based product. So I have the ability to get it from somebody else at a much higher cost, but a much shorter lead time. So in this scenario, I could simply toggle that to say, let's go ahead and buy it from them. And I could also define the time frame, so maybe just do it for the next month only. But the cool thing about the solution, you notice the priority. This is where the question came up earlier around optimization. My priority 1 is always going to be use the low cost material. My priority 2 will only be invoked and used when I run out of supply of that priority 1. And so even though I have, in essence, the best way to think of this is I will use priority 1 all the time outside of 20 days. And then if I run into an issue where I need additional supply and I've got no choice, I will pull in and use it within 4 days. So now I click save. Again, remember when I click save, we're illustrating the concept of concurrency. It's going to immediately resolve that plan and that issue, and you see the impact of that adjustment. Now, if I'm happy with that plan and I like what I've done, all I need to do is to say, okay, that scenario, I want to use it. Remember, the concept of scenarios, we also have the ability to commit them. So when I commit that scenario, I'm committing it up to my live control tower instance here. I click OK. It's now committed that change. I come back to the dashboard, hit refresh. And I now, if I did everything correctly, should have resolved, in this case, I resolved some of the issues, but not all of the issues. Because remember, I had other gating materials as well. If I drill in, notice the D2512 is now gone. And I have other issues that I now need to address in order to fully fix my supply chain. So on those shipments, I had more than just one material. I had multiple materials. And so I would just continue that process to help resolve and evaluate the best ways to fix the supply chain based upon the issue that occurred. And then last but not least, if I run each of those different scenarios, and just to kind of tie the story together here, I would be able to compare any of the scenarios that I ran one against the other, just like I did before, to see the potential financial implications of each of those different scenarios. So a couple other things I could have done in this situation is I ran the alternate supplier, which I demonstrated clearly to you how we did that. I could have shared that material equally across each of the different customers, and that would have changed the customer fulfillment profile. I could have fair shared it based upon contribution of demand for each of those key customers. And then last but not least, I could have prioritized key customers, serviced them, in other words, stolen from Peter to pay Paul, and controlled who got the supply and who did not get the supply. In this particular situation, each of these three examples are using the supply as it is, and this guy here was resolving that supply shortage, even though it's going to take a big hit in terms of my cost of goods sold and my margin. In this case, I go from 43% to 43.01%, so not a tremendously huge hit, but I actually take a bigger hit when I don't service my more important customers. So this gives me the ability to view all that from a financial perspective. And I mentioned before that, one of the key things about supply chain is tying that all back to the finances as well. Okay, so that was our second demo vignette. Pause there. Are there any questions? If anybody's reading the chat, are there any questions on the chat, or are there any questions from the audience at large?
No questions on the chat right now, Trent.
Okay. Excellent. All right, so let's continue. So the next thing we'd like to do is we'd like to dive a little bit deeper. So what we've been talking about is kind of at the planning level, although we were near real time with the supply disruption, handling and addressing supply disruptions. But what we want to look at now is the actual execution at the detailed level inside the four walls of a manufacturing facility. So inside the four walls of a manufacturing facility, I need to be able to look at each of my individual production assets. I need to be able to look at the material availability that I have. I need to be able to look at the sequence of production from one stage of production to the next and between different jobs on the same stage of production. So in this example here, what we're seeing is I've got two different manufacturing lines that are potentially producing, and this is a simplified example, but producing a drug, if you will, and then I'm packaging that drug out into blister pack or various different packaging configurations, carton pack, et cetera, et cetera. And I need to be able to take the production requirements that I have, which are represented down below by these jobs you see, and manufacture those in the most efficient manner on the manufacturing shop floor. So the whole idea here is to optimize based upon minimizing changeovers, meeting orders on time, and so on and so forth. Okay, so let's take a simple example first. I just want to show you some of the constraints and the capabilities that are available in the system. So I have multiple finished products that I'm producing, as well as multiple work in processes that I'm producing. I'm going to pick one of these. And first thing I'm going to point out with everything within this solution is all the click and drag and interactivity that is available within this solution. So first of all, I'm going to take one of my whip jobs and move it up and drop it on the manufacturing line. So all I've done there is I basically said for this first job, it's now scheduled on June 2nd, 4:13 p.m. It's going to end at 11:13 p.m. So I'm making one batch for this quantity of this particular job on that line. You can see if I zoom in, and by the way, just to kind of give you a sense of what I'm looking at for the overall schedule, let me zoom into this job first. 7,000 units, 7 hours, an overall 7-hour run. If I zoom out the other way, you can see that I'm looking at a multi-week schedule. And in that schedule, I've got multiple shifts defined. So I've got shift 1, shift 2, shift 3 during each one of my individual days throughout that particular week. Okay. So let's just kind of zoom right about here so we can kind of see what's happening. I'm going to pick another order for WIP 21. WIP 21 can be made on one of two manufacturing lines. So I can make it on A or I can make it on B. The system knows I can make it on both and understands the constraints of that and the fact that I have to respect that constraint. Let me go pick another work in process and let's pull that up and let's do the same thing. Put it on 1 and put it on 2. Now we have intermediate product available that we can go ahead and schedule the finished good. If I had tried to schedule this finished good without scheduling any of those intermediates, I would not have been able to put that on the schedule because it simply didn't have the capacity in terms of the intermediate product in order to make that happen. So let's just pick a couple of these guys. I know that these packaging jobs can be run on that line there, and I'll pick one more just to kind of make the example a little bit faster, and I'll drop this guy on my manufacturing line too. So what I want to point out, and let's zoom in a little bit closer here so we can kind of see what exactly is happening here. Notice the click and drag. I can move around anywhere I want to, zoom in, zoom out. Very flexible in the sense that I can very specifically focus on what I want to within the schedule and zoom out where it makes sense. So if I were to click on any of these jobs, what the system is going to do is it's going to show me the relationship. So I can't have produced this finished product here without producing the work in process that's going to feed it. Likewise, I can't produce this finished product without producing the work in process that's going to feed it. In some cases, this batch here doesn't have any downstream jobs tied to it because I scheduled it independently. And if I look at this one as an example and say, okay, I want to move this. So full click and drag is enabled here. So if I want to move this and I try to move it up here earlier in the horizon, what you're going to see is that it doesn't allow me to do that. And the reason why is because I've got a constraint of I have to have this upstream supply available before I can produce it. Notice in this case, I didn't hard allocate it to the batch, so it actually reverted to another batch, but it still has to have the upstream supply before it can produce. If I were to move the batch back in time, then I could adjust it. And you notice it tells me where I could drag it because this is where the constraint is existing in terms of the work in process being available. Okay. Now it's interesting to click and drag and move one job at a time, but that's not really what the point of a system like this is. Then I might as well be scheduling manually in Microsoft Excel or on a Gantt chart in the production room. So what we want to be able to do is we want to be able to automate this entire process. So first and foremost, if I click on my rules, what we'll notice is I have multiple different optimization rules I can access. So first, I have the ability to say, what are rules specific to delivery, or what are rules specific to productivity? I can also look at things tied to my financials. For the moment, and we'll come back to this, I want to just focus on due date performance. Okay, so that's all we're focusing on right now is making everything as close to just in time as possible. Not even delivery performance, more of JIT or just in time performance. So let me just, first of all, select all jobs. Let's take our filter off. I'm going to select all the jobs and I'm going to unschedule them. And now I'm going to click on the optimize button. And notice down below, I have 452 jobs. It just took those 452 jobs and literally, and I can tell you exactly how much time in this case, you don't need a stopwatch, 413 milliseconds. It generated a schedule for those 452 jobs. Okay. So now if I were to zoom out on the overall horizon, you can see that I've got what, 1, 2, 3, 4, 5, 6, 7 weeks of production representing those 452 jobs. And it's done that based upon the rules that I said of trying to minimize or trying to make everything, if you will, just in time. So let's zoom back into the first part of the period here. And now let's talk a little bit about what I'm seeing on the schedule. So first of all, we have this capability to look at different labels. So I'll turn this one off for 1 second. The first label here is telling me the product type. So brown is a specific drug, allopurin. Purple is another specific drug, ibuprofen. Light gray is amoxicillin, and so on and so forth. And then as I get into the packaging line, I have additional attributes. And those attributes are driven by the different packaging setups. So if I drill into these, I can see that there's a specific pack. Let's see what there is there. So pack size, 300 count, blister pack, and so forth. So the green is the attributes associated with packaging. The layer above that is the attributes associated with the drug, and so on and so forth, or the color, excuse me, associated with the drug. So what I'm able to see is I can color code my schedule based upon product-based attributes. But I could also look at process attributes. So notice here in the process, I could look at setup, runtime, post-process storage, and so forth. So if I click on this guy and click Save and Close, what you can now see is the setup times that are necessary to switch from batch to batch, from packaging run to packaging run, and so forth in order for me to create this schedule. So if I zoom out, you're going to see quite a bit of those white spaces representing that setup time. And I could even see it a little bit more holistically by pulling up my KPIs. So when I pull up my KPIs, I'm able to see that, okay, I have very few late jobs because remember the objective function that I asked it to address was minimizing late jobs, but I have a lot of setup time and changeover time. So right now in the schedule, I have 535 hours of setup time. So I want the system to do better than this. I don't want it to just minimize my late jobs. I want it to basically minimize late jobs plus setups plus finished good carrying costs. And right now the number is 10,700 in terms of the monetary impact of the schedule as it currently stands. So what I could do, and let me just close the jobs window here because I don't need to see that right now, is I could modify those rules. So in addition to having a rule around earliest job need date, let's also focus on things like productivity. And in particular, let's focus on this guy, which says least setup hours, and let's weight that as well. So now what you're seeing is I've got a weighting on delivery time, earliest job need date. I've also got a weighting on productivity, which I've weighted as, you know, a little bit more important, if you will, than the earliest job need date. And I'm going to use those two things in combination in order to generate and optimize that schedule. So I'll hit save and close. And I'm going to keep this KPI view open because what I'd like to do is to compare. What you'll notice here is that it'll always show me the current schedule, and it will also show me the last schedule that was created. So my KPIs will give me the ability to compare both of these side by side when I generate the new schedule. So I've changed the optimization rules. I'm going to simply re-optimize. So I click the re-optimization. Again, 411 milliseconds to perform that. And what you're going to notice is the difference. So yes, I have 452 jobs, and I now have 51 jobs that are late. But I've gone from that 10,000, which was 7,460 greater than where I'm at right now, to 3,240 in terms of really my objective function, which is minimizing late penalties, minimizing setups, and minimizing carrying costs. And also I've gone from, if you remember, 535 setup hours to 162 setup hours. So this is the one that really drove a tremendous change based upon the adjustment that I made, which makes perfect sense because I included that additional metric, if you will, in the optimization. Now, one interesting thing is you might, for those paying a lot of attention here, you might look at these different rules and say, well, how do I know, you know, I've got delivery, I've got productivity, I've got financial, you know, profit, revenue, setup costs, et cetera, et cetera. There's a lot of different levers that you could adjust to create and optimize what you want to do for that schedule. How do I know as a user what I should be setting these to? Well, that's great because we got you covered there. So I have the ability to ask the system to essentially optimize that on my behalf. So really what we're doing is we're using something that we call Copilot, which is saying, okay, I don't want to take the time to figure out which one of those parameters I want. What I really want to do is I want to optimize based upon this KPI, which again is a combination of the late penalty costs, the setup costs, and the finished good carrying costs. Those are the three things that I care most about. So I'm going to use those rules on manufacturing and pack. I'm going to allow the system to use the rule seek, and I'm going to use that Copilot. And so what this is going to do is when I'm not doing anything within the system, it's just going to, in what I'll call idle time within the system, it's going to just be out there computing based upon the jobs that it has. What is the best combination of weights to apply to come up with the lowest level of penalty, setup, and finished good carrying cost? So I'll hit save and close. And what it will do in the background is it'll run this Copilot optimization in my idle time, and it'll come up with a better number for the late penalty, setup, and finished good carrying costs, and present that to me when it's completed with that particular optimization. At the top, you'll notice, and again, we have scenarios here as well. So the scenario that I was in was scheduling baseline 7. Notice at the top that it's already giving me some potential examples to look at. So late penalty plus setup plus finished good carrying cost. It's got one example where it's down to 3,200, which was lower than our 3240 down here. It's got another example that's a 2560. So it's already doing the work of trying to come up with better schedules. If I were to click on one of these, excuse me, it'll actually show me the resulting schedule. So you notice the schedule just updated, and this says here a Copilot rule seek. So it's giving me an output. And I think what you'll notice in this output, remember that the whites are change over time. The jobs that are in different colors on manufacturing, so that all the browns are together, all the light browns are together, all the purples are together. So I can look at this schedule very quickly, just as a complete scheduling layman, and see that this is a really good schedule compared to what I had before. And notice now I had 55 or 51 late jobs. but I've taken the total calendar setup time down to 128, which is the lowest I've seen it in all those combinations. And also the finished good carrying cost has been reduced by making things more around the time of exactly when they need to be produced, as opposed to making them super early or super late. And the overall late set penalty plus setup plus finished good carrying cost is now down to 2560. If I look up here at the top, there is a diminishing, time to diminishing returns. It looks like that's about the best that the system was able to achieve. But hopefully you've seen that it achieved that pretty darn quickly and was able to get to a pretty good schedule within a very short period of time. So I'm going to pause there. That was the scheduling example. So we've done, just to recap on all three, the S&OP example, the kind of a control tower disruption in the near term example, and now we focused on how we can optimize inside the four walls of the plant what the detailed manufacturing schedule would look like.
Thanks, Trent. This is Akash. So there are a couple of questions on the chat window, and I'll read out them to you one by one. You could provide a response.
Please.
Yeah. So the first one, and this came towards the end of your previous demo, right, which was around the control tower and the disruption. There's a question from Abhay which says, is there any sensitivity analysis that prioritizes which input is going to create a bigger impact?
Sensitivity analysis. Yeah.
So if
the answer, I guess, in terms of the inputs, in terms of the disruptions, which one would cause a bigger impact on the overall supply chain? Is that the question?
Yes, I would assume so. Abhay, if you provide any clarification.
Okay. So let me answer that the way I understand it. I would be able to look at each one of the material disruptions that occurred, and I would be able to do a where used analysis of showing me where the production plan was affected and the amount of, both quantity and dollars of that affected finished good production plan based upon each individual material. And we can do that because the system has full demand and supply pegging up and down the supply chain. And because it can do that, I can actually tie each material shortage to all of the upstream, or I should say downstream, downstream orders that it's affecting, and also monetize that. So the answer in that sense, if that's the question, the answer is yes.
So there is a clarification that has come from Abhay, and he says that input means capacity, raw material. If raw material, which raw material is creating maximum disruption? Right?
Yes. And so the answer is, if maximum disruption is defined in terms of the most units affected or the highest dollar affected, the answer is yes.
Got it. So in effect, Trent, you're saying that you should, for the planner, he would be able to understand which input parameter is causing the maximum disruption and run scenarios to identify alternates, to make that disruption move away, right? Is that a right conclusion, what you think?
That is 100% correct.
So Abhay, please do follow up with that in case you haven't got your answer. I'll move on to the second question and I'll come back to this in case you have a clarification. So the second question is from Mohammed Ruman, and he asks, how is this different from SAP, IPA, PPDS?
Well, I can't claim to be 100% of an expert in PPDS, but my understanding of the difference would be the ability to handle more complexity here, the ability to address optimization of changeovers, multi-stage, expiry inventory between stages. I think that we could potentially take that as a follow-up, because I know we have some research internally on some of the things that PPDS can do, and I just don't have them at my fingertips off the top of my head. But we've done an analysis of what can we do better than PPDS, and we'd be happy to package that up and share it.
Potentially, the only thing I would add there, Trent, would be the ability to run these scenarios and the number of optimization parameters that you called out, which were running to the tune of 40 or 50. I am not sure if all of those exist in a PPDS. So I guess clearly from a scenario planning and objective functions that can be enabled, which are pre-configured, I think that would stand out. But yeah, it'll be good for you to share, what are some of the differences with the group, and we can circulate that.
Yep. And we can funnel that to you, to the Accenture team, and you guys can distribute it. Does that sound fair?
That is fine.
Okay.
Then there's a question from Sandeep, which says, would this scheduling module consider material intermediary delays live from ERP, or this is also based on scheduled ERP syncs?
Repeat that, please.
Okay. So it says, would this scheduling module consider material intermediary delays live from ERP, or this is also based on scheduled ERP syncs?
Okay. So essentially, the model you're looking at here is fully material constrained. As to where you leave off with the scheduling model and where you bring in. So as an example, in this case, I'm scheduling the WIP and I'm scheduling the finished good. If I had more upstream operations that I wanted to schedule, I could do that. But I could also use those upstream operations as an input and just say, here is the availability of material and the date that that material is available. So it's really, in my mind, if I understand the question correctly, it's a modeling decision. At what point do I want to, feed in inputs into the schedule, and at what point do I want the schedule to actually the scheduling system to actually schedule that job and use that scheduled date and time as the availability date of the material.
So Akash, in interest of time, I would suggest that if there are questions, we can offline, right? And we can respond to the individuals one-on-one, because there's still one more demo to go, right? And we have some ground to cover. So I think that's
actually that was the last demo.
Okay, cool. All right.
Yeah.
Yep. It was I was expecting a little bit more questions during the middle, I guess, which is maybe why I timed it the way I did. But so I'm okay with questions now, or we can take them follow up.
Then we can take a few more.
You guys.
No, we can take a couple of more questions. Sure.
Yeah, let's do that.
Yeah. So there's a follow-on question from Abhay, which says, are you also limiting the run in simulation to get faster optimized response? Is it compromising accuracy? I saw performance on screen. So maybe just, how does this really happen in real life versus a simulation? Yeah. Is there any difference?
Yeah. And by the way, you can control how fast you want this to, this is the Copilot example, right? How fast you want this to run, how long it needs to be idle before it'll actually start using it, and so forth, right? So again, the whole premise of both our scheduling capabilities and our planning capabilities is speed. And so I get this question a lot in demos of, well, okay, great, that was a demo and it was really fast and it looked great, but what does it look like in production? And again, I would say production maybe isn't less than a second necessarily, but the whole idea of everything that we're trying to do is that the answer comes back very fast. And so it's hard for me to say, okay, instead of a second, it's a minute or 40 seconds or whatever. I don't have a specific answer for that, but it's not a batch job that takes hours or anything of that nature. So we are focused on, getting you a very fast answer, and speed is a big tenet of everything that we're trying to do.
Yeah. I think Bob has also responded stating that it's almost near zero latency.
Yep.
Any more questions that Trent on the product or on the demo from anyone? You could type it on the chat window, or you could ask it, and we could take it up right now.
Okay. Well, certainly I appreciate everybody's attention today. I mean, it was a great opportunity to be able to present our solution. We're super thrilled of the interest in Kinaxis, and I know there's some additional topics, so there's some additional agenda topics. I'll turn it back over to the Accenture team.
Yeah, No, thanks, Trent. And I guess this is not the end of the conversation anyway. In case people have clarifications and input, they can always reach out to us and we'll sort of connect and respond.
Absolutely.
Inputs, right? So thank you so much. Niladri, if you could get the presentation up again, we could move to the next section. Right. So with that, now we are through with the solution demo and getting a feel of what capabilities it brings, what are the advantages we could have by deploying this. Let's move to talking a little bit about the partnership of Accenture and Kinaxis and some of the client stories where we have partnered to really deploy the solution. So Vismay, over to you, and then I'll come in.
Thanks, Akash. So good evening to everyone, and thank you to IPA for this tremendous opportunity and for the opportunity to present to such an esteemed audience. So before Akash and I speak about the two case studies, I did want to discuss how did we get here? What is it that we have done over the last 10 odd years with Kinaxis to shape tremendous client journeys in the space of supply chain? So what allows us to make an impact for mostly for a lot of life sciences clients across the globe is that we've been investing in digital and specifically digital supply chain with Kinaxis for over a decade now. We are the largest implementation partner of Kinaxis globally, and we've run multiple global complex transformations with them for the last 10 years or so. We have a very large pool of capability available in India, but also in multiple places globally that allows us to cover a very wide geographic footprint for clients that would operate out of large number of countries. So far, we have done 14 plus successful deployments with Kinaxis for very large pharma companies, including the very first together for a pharma company in India, and we are very proud of it. And lastly, we've been engaging very significantly with Kinaxis to influence their product roadmap. What do clients need? We take the experience back to them, and we've been seeding a lot of thought leadership to make sure that as the focus on digitization increases, we are able to cater as best as we can to clients with a very high focus on life sciences. So that's a snapshot of Accenture's relationship with Kinaxis over the last few years. I will move on to discuss the first case study first, and then I'll hand it over to Akash. So this case study is for a large life sciences company that is based out of France. The company has a very large footprint across the globe. They have markets in 170 plus countries. They have manufacturing sites in about 73 odd locations, and they have 5 odd business units, all the way from biologics, drugs to consumer healthcare. So it's a very complex business that they operate, very complex supply chain, and they have manufacturing plants in India as well. Given this complexity, the challenges they faced are not, I mean, when you look at the challenges here, most of you may be able to resonate or relate to them in some form or fashion. But the client, obviously, given the disparity of operations, had a very heterogeneous way of functioning. The processes that were adopted or being used across the different markets and plants were very different. They had a fragmented tool set when it came to running their supply chain and even the execution. So the way they were operating in different markets was very different. And there was really no way for them to share information end to end, even though from a physical flow of goods, there was a lot of dependence on countries like India and China. There was really no integration from an IT or a digitization standpoint that would allow them to understand what's going on, to manage risks or disruptions as they happen. And a consequence of all of that was significant time and effort being spent on doing things manually, on coordinating things across the globe manually, and lack of agility and responsiveness when it came to managing disruptions. Over time, so this has not been a short journey. We'll talk about it in the next slide, but the journey has been on with this client for the last 4 odd years. And over time, the client has focused on first setting the fundamentals right. So the client started in 2016 with just qualifying internally the opportunity and making sure that when they embark on a journey like this, they are sure of where they want to focus on, what kind of capabilities they want to focus on, and what this would mean in terms of returns for them. The first year they focused on designing the solution, focusing on how best to go about the digitization journey. Given the complexity at hand, the client was aware that it is not possible to bite the whole chunk in one piece. So they really carved out a roadmap for themselves where they went phase by phase. So the first year they focused on designing the solution. The second year was phased on building what they called as a lead model, or what we call in a traditional sense as the minimum scalable product. And then since 2019, they have been deploying the solution across the globe. So far, the solution has been deployed across 60 odd countries and 30 odd plants, and the journey goes on. And Ladri, going back to the previous slide. So if I summarize the capabilities that the client has really focused on, is number one, digitizing the end-to-end planning function. So the focus really has been on making sure that demand, supply, SNOP, and production planning, all of those key functions talk to each other really well. They also have very large number of CMOs, almost 300 odd contract manufacturers. So one of the core focus was also to make sure that they are able to uh, integrate these contract manufacturers into their own planning and execution ecosystem. And most importantly, what has yielded significant outcomes for them is scenario planning and real-time collaboration. And this was most evident during the current pandemic, where a lot of their sourcing still is dependent on countries like India and China. And with scenario planning that was already live in 50 plus markets at the time when the pandemic hit, they were at the forefront of being able to deal with this disruption extremely well. What really motivated them in terms of business outcomes was one, their strong focus on making sure that with this digitization, they are able to improve availability across markets. Given the complexity, I think without this kind of integration, this would not have been possible. And the second big lever was inventory. This client specifically had about $1 billion worth of inventory reduction as target as part of this journey. And they have been able to achieve a significant portion of that till date. So this is a very interesting case study, simply because of the complexity that inherently came with such a large footprint. Also the fact that the markets were quite disparate and a lot of similarity to the kind of operations we see in India. And also one of the leaders in terms of embarking on digitization that has allowed them to really create visibility across their entire supply chain, and views that the leadership can use to make decisions very rapidly. With that, I'll take a pause. I've covered the most key elements of the case study. I'm cognizant of time, so I'll keep it short, but I'm happy to take any questions at this point or later.
Let's keep moving, Vishnu.
Okay.
Thanks, Vismay. So from one large pharma client where Accenture and Kinaxis partnered to really drive an integrated solution to another. This was at Merck, or MSD as it's called in North America, where Accenture and Kinaxis combined to deliver an integrated, concurrent and collaborative planning solution. So a little bit of, most of us are very well aware of the firm. So with about 46.8 billion of revenue, it is one of the largest pharma companies globally. And of course, that brings with it its own set of complexities, right? So there is, the company had presence in more than 100 markets, thousands of suppliers, 4 BUs, thousands of supply chain users. And some of the challenges that they faced effectively included the multiple disparate, disconnected systems across regions, across geographies, across business, which meant that there was always a lack of visibility. There wasn't a unifying common planning platform that connected demand to supply or to distributors or to inventory, which meant that meeting delivery commitments to the customers in a profitable manner at times became a challenge. There was no end-to-end planning view, no end-to-end execution view. There was also a lack of harmonized, consistent processes. which effectively meant that there were challenges that the company faced in terms of agility or responsiveness, right? So all of these are challenges that they were facing. At the same time, they also see, while they thought about a supply chain transformation, they sort of thought of looking at getting inspiration from outside the industry, and they looked at CPG, consumer goods industry, as one source of inspiration. Where, for example, while they were carrying on an average of 258 days of inventory, a consumer goods company globally was carrying 60 to 70 days, right? So they said one of the thoughts that went into sort of looking at this program was also to seek inspiration from practices not only within the industry but outside the industry, and fundamentally challenge some of the ways that the supply chain was run. So that's where Accenture and Kinaxis collaborated. The rapid response platform was deployed for the client. Some of the key capabilities that were delivered were, what we covered earlier. So we looked at scenario planning. We established the concurrent planning platform, which included aspects of forecasting, demand planning, supply planning, scheduling, control tower. Enabled collaboration. This was deployed at about 450 suppliers, stroke contract manufacturers, which meant that almost 98% of their supply chain was covered in this, right? And essentially, from an outcome perspective, what this meant was that now Merck has a platform which is integrated, gives them end-to-end visibility, helps them take faster decisions, through scenario planning, ability to close the loop on execution, right? They sort of deployed segmented replenishment strategies across their market and geographies, and now they're able to really drive a lot of exception-based planning, right? So those were some of the outputs that they received, they achieved, and of course there was a financial benefit. Christian did mention on the chat window earlier that there was almost a $300 million ROI that Merck achieved out of this. That there was almost a 200 million benefit on inventory and on order management, specifically around tenders. So they were having stockouts on tenders, and they were able to manage that a lot better. So this really is what was done for Merck. We would be sharing this presentation with you, and what you would see towards the end of the slide is a link that will take you to a video that talks about, that has Brian Thomley, who's the VP of Supply Chain at Merck, talk about their journey. I would request you to hear him out. It's a wonderful articulation of the challenges and how they completed this journey from the person who was in the hot seat driving this transformation. So I think with that, any questions around the case study? Any questions or any inputs that you might have before we move to sort of towards the closing remarks on the section? We have about 5 minutes left only. Okay. So I think then with that, I would thank all of you for taking out time, giving us these 2 hours to attend the session. I do hope the session was useful to all of you. We did have many people, talking about some very pertinent and important things. To begin with, we heard Mr. Jain and Mr. Belapure speak about the need for a resilient supply chain. We heard Rishabh then come in and talk about the challenges that we are facing from a supply chain in India, and what are the impact and why really we need to move towards a customer-centric supply chain. We heard Christian speak about Kinaxis, the platform, its leadership in the life sciences industry, and how the tool is evolving with ever-increasing implementations. We then had Trent, who covered 3 scenarios or 3 demos about the tool capabilities in terms of a regular SNOP cycle, exceptions during the execution cycle, which is related to the control tower, and finally a detailed schedule and optimizing really the shop floor execution plans. And then finally, we had a view around the partnership between Accenture and Kinaxis and some of our work that we've been doing together for global life sciences clients. So that's really something that we covered today. All of you have been wonderful audience. Thanks a lot for all the questions that you asked. We will continue to engage with you. We will share this. in case there are any clarifications, any subsequent detailed discussions you want to have, please do reach out to us. Niladri, if you could move on to the next slide. These are the key contacts for you to refer to, and we would be happy to respond and have subsequent detailed sessions with you. So with that, so I'm just quickly having a read on these sessions in case anyone if there's any question I could ask. Yeah, thank you. Okay, thank you everyone. Appreciate the time and look forward to connecting with you. Thank you to members from Kinaxis, and thanks a lot to IPA for giving us this this wonderful opportunity. Rishabh.
Yeah, thank you so much. Thank you everyone. Final closing comments from your side or from Mr. Belapudi?
Thanks a lot to the Accenture team and Kinaxis team. This was a very insightful session, and I'm sure everybody in the audience would have found this really helpful and useful. I've been recording this session. I will share the recording with the participants right after the session. And then, of course, we can open it for further questions offline. If somebody has it, they can reach out to the Accenture team.
Thank you so much for giving us 2 hours on a weekday. Appreciate it.